Okay, so we have cruised on up from Canterbury to the NEC this morning. A nice warm morning. I'm going to be wandering around, going on at stands, seeing signs for things that might be new, and then investigating those, ready to do lots of little video clips as a post-show review. So 4 shows today. We're starting at Advanced Materials. We're then going to be going to Advanced Ceramics. We've got the Battery Cells and Systems Expo and Vehicle Electrification. For a more sustainable world, we're going to have a little bit more of the mega trend of electrification. Electrification is going to require alternative energy sources. A lot of those alternative energy sources need storage, often in the form of batteries. And batteries are made typically from some of the most advanced materials. So we've got a nice little loop of editorial content here, which will hopefully be both interesting and useful to our readers of SE Magazine and our audience of the World Made Better podcast series. So I'll leave it there. One final thing to say is this is the first time in 60 years that I've attended an exhibition in shorts. So that's a world first, and it's due to being a rather warm day. So see you on the other side. Right, here we are at Advanced Materials Show 2026, and we are now on the Jiva Materials stand, and I'm with Jack Herring, and we're going to talk about Soluboard, the world's first biodegradable printed circuit board. And I think the first thing we should do is just take a look at that little poster up there, because this material is the Logitech Future Positive Challenge winner 2025. So congratulations on that. And I think there's some more winning stuff that you can announce more recently when you were in Holland, was it?
Yes.
Yeah. So tell us about that.
Yeah, we were recently exhibiting at the Hello Tomorrow show in Amsterdam. We were fortunate enough to be announced as one of the winners of the environmental protection tracks sponsored by L'Oreal. So yeah, we were one of 13 winners out of close to 5,000 applicants. So we're very, very proud of that.
Yeah, brilliant news. And it's all about the material and its applications. So I thought we'd just have a very quick look. This is the reinforcement material that goes together with the binder to make the copper-clad laminate that we see here, that then ends up as printed circuit boards such as these and these. So, Jack, can you talk us through, if we just use these boards as examples, I think we're looking here at a board that is comboing supercapacitors and PV cells. Yeah. So just talk us through these applications that are obviously sustainability oriented.
Yeah, sure. So the idea of these projects is to remove the need for single-use battery cells. So this was a project that we did with Nexperia, a company called Ligner Energy, who make supercapacitors, which remove the need for single-use battery technology. And this is powered by ambient lighting just in the room, effectively. So this technology was then translated into another application for a real-world design using a remote control platform. So the idea is that you could have this PV cell powering the supercapacitor, harvesting energy from the ambient environment, and it will allow you to work the likes of your TV or various other applications, your AC units, things like that. It's all about reducing the need of single-use devices, effectively.
Yeah. And so, what we're looking at here is obviously a kind of full sustainability circularity type project, isn't it? So reducing the environmental impact of the energy generation, energy storage, and then end of life with the board and components themselves. So full circularity in that. Yeah, it's wonderful to see these types of projects underway. Obviously every month with SE Magazine we're doing case studies of this type of work. So yeah, congratulations on your wins. Congratulations on these applications. And we look forward to tracking this technology as it rolls out into commerce.
Yeah. So we're here at the Advanced Materials show as well, trying to expand our coverage here in the UK as well, trying to find some more UK-based customers. We've had great engagement across Europe and across the world, but the UK is a place that we need to expand our messaging and let people know exactly what we're trying to do.
Yeah, brilliant. Well, I hope you have a very good show. And yeah, just looking at these boards, impossible to tell that this is a biodegradable PCB.
Yep, that's what I want to hear.
And that's got to be the name of the game. And with our trip to Ghana Osborne, when we watch these being made, also sort of process agnostic. So no process changes and a board that certainly looks and feels the part. So yeah, great to see. Have a good show. Thank you very much.
It's great. Thank you. Nice to see you again.
Here we are on the CHT stand, and I'm with Ian Taylor, and we stopped here because we saw a poster up there saying weight reduction, and obviously in sort of mobile applications, vehicles, aircraft, trains, etc. The less you have to move around, the less energy is required, and the lower the carbon footprint, the more sustainable the end product. And so we're here to have a look at two material technologies that contribute to weight reduction. So Ian, over to you. Talk us through what these are and how they work and what the benefits are.
Absolutely, John. So the company I represent is CHT UK. We manufacture silicones for all different types of environments. And what we're seeing at the moment is a massive influx in lightweight applications. Initially, we developed a product similar to this, which is for lightweight products at depth for water blocking of umbilicals and cables and things like that. So inside of this is glass beads, very lightweight, around about 0.58 density. But because there's glass beads in there, it can withstand some serious pressure at depth. So that's what it was originally designed for. But what we're seeing now is drone applications, lightweight applications, where customers need to shave off the weight because of costs. So we've got an application where in a manned drone, a huge drone with 4 propellers on it, on the electric motor, it's actually potted to protect the electronics with this product, which is quite interesting. So yeah, from deep sea right through to, we're going up, up in the air now. That seems to be quite good. The other application we have is a silicone foam. It's a lightweight foam. It's a liquid. It starts off as a liquid. And what actually happens is once you dispense A and B, a chemical reaction occurs. And it's what we call a self-blowing silicone. And the benefits of this product is, again, we spoke earlier, John, lightweight. Secondly, we spoke about vibration dampening. It has ULV 94V0 against it. And it also is flame retardant. So if you have a catastrophic event with one of the batteries, this will help prevent. It won't necessarily stop, it will help prevent thermal propagation from cell to cell.
Right.
So 90 seconds that will start to gel off.
Yeah.
But we have a version 2 that we're working on, because sometimes you need longer to get into the component and actually flood it before it kicks in with the chemistry. So yeah, we're quite proud of what we do here at CHT, and I think this is just the start of some of the products that we offer. We're based down in Bridgewater in Somerset, where we do our own manufacturing. We've got our own technical team, our own R&D team. So, yeah, brilliant. I appreciate the time, John.
Yeah, well, thank you very much for that. Obviously, with electrification speeding along, I'd imagine a lot more companies now looking at battery packs maybe for the first time.
Yes, absolutely.
So new to this, so you've got technical staff, and you can tune the product to the application if necessary.
That's the benefit of CHT for sure. What we are is the bespoke applications.
Right.
So we do a list of products, a plethora of products. However, if a customer comes to us and said, Ian, I like this product, but we need it slightly thicker viscosity, or we need a higher thermal number, that's why CHT have that bespoke application. That's what makes us a little bit different from a lot of our competitors, to be honest. So
Yeah, very interesting. And also interesting with the drone work. We're doing a lot of coverage at the moment with drone applications, both sort of civil and military.
Yep.
And yeah, those big, high-speed, brushless motors,
Exactly.
high RPM, high vibration. So I get the vibration damping and the potting of those. That makes a lot of sense.
Yeah.
So yeah, we'll keep an eye on what you guys are doing. As your applications come out, then we'll stay in touch. So thank you very much for your time. Right, here we are again at Advanced Materials 2026, and I'm on the Lios stand with Eimear. And we are looking at a fascinating material technology, which is all based around acoustic management. I guess that's the right way to say it. And so my first question is, what problem would our readers and viewers be facing for this technology to be the answer?
So the problem that we're solving is the problem of noise and vibration in the world. The world is a very noisy place, and things like your dishwasher, the office building that you work in, the plane that you might have traveled here in, these are all very noisy products and environments, and SoundBounce tackles that noise, reducing it, and it's a more sustainable and space-saving solution compared to traditional materials there.
Fascinating. Right, well, before we started to speak, I did see some samples here, and it looks like an interesting technology. So talk us through, please, the kind of constituent parts. I can see a grid, I can see a fabric, I can see a gel. How does all of that come together to give you a material that is superior to existing materials?
Yes. So SoundBounce is a composite material, an advanced material, and it's made up of two parts. So we have our cellular structure here, and into these cellular structures we house advanced materials. These advanced materials are thixotropic materials, and these are special gels that are more solid-like when they're at rest, but they flow more and have a more liquid texture when they are exposed to energy. So in our case, we're dealing with sound energy, vibration energy, and some household examples of materials like this would be honey, paint, ketchup. So we take these materials, we house them in our cell structure, and then we seal that in. So you get tiles like these. Obviously, we can do these in much bigger sizes and different shapes as well. But fundamentally, what this helps to do is to dampen and reduce noise and vibration in the construction industry, home appliances, aerospace, transport, and in automotive as well.
Okay. I can see here, this looks like a 3D print. I'm guessing this is sort of prototyping type work. I'm interested to know, when you go to production, what sort of processes would you use in terms of volume manufacture, that type of thing? And a real trick question is, how do you fix that? How do you bond those two things together with the gel in the middle? What's the secret there?
I might not tell you the secret. So yeah, we're actually at a really exciting time right now. Our pilot production has just kicked off. We've got parts coming off the line in Q4, so we're really ramping up into our pre-market trials, pre-market validation for certification, with parts coming onto the market in 2027. So we're really in that transition. We do use quite a lot of different 3D printing techniques and have used many for rapid prototyping, for understanding the technology and what we can produce. So you're correct in saying these are 3D printed. What we're doing now as we move towards more scaled production is we'll be using injection mold techniques and others. The sealing, it turns out, is pretty tricky to do. So we're actually going to keep that under our hat because that's been a much harder problem to solve than we initially thought. But we've worked with some excellent partners across Europe, in Ireland, where our production is based in Ireland as well, where the company is based, and some partners in North America as well to work on what have been really challenging technical production issues, but we've really, through again collaboration and partnership, we've been able to create a really effective production process that's going to bring us both the pre-market levels of production, but also is going to scale us right through into mass production towards 2030.
Okay, so I'm just imagining if I disassembled my dishwasher, at the moment I imagine from recollection see some sound deadening type products in there, and so the idea is that this would replace that material in that type of environment. And with the little summary we did for you guys in our magazine this month, one of the applications I think was space. So space can be very cold and very hot, and getting there can be very, how can I put it? It can be a rough journey. How does it stand up to that type of environment? I assume that's probably the most extreme thing you've engineered for.
Yeah, space is an extreme environment, and we've been very fortunate that we've been working with the European Space Agency through several different commercial contracts since 2021. And through that work, we've been working on evolving and kind of demonstrating how SoundBounce could work in those really extreme environments. So we've been working on lightweighting the technology, which obviously has knock-on benefits in commercial aviation and automotive as well. You're a little closer to the ground. And we've been working on acoustic protection in the fairing. So this is the piece right up in the nose cone that contains the payloads, so things like satellites, delicate instrumentation, things you really don't want to get damaged on that last leg of its journey after it's been assembled and probably spent maybe millions of euro at this stage. So we're replacing the fairing acoustic protection with a better form that's going to protect it, particularly during the launch stage, where those decibel levels are getting up to 130, 140 decibels, really extreme, and the separation stage when the leaves of the nose cone open. So we do have to meet pretty high specs for that, and that's a piece of work that we're engaged in right now. Our third phase of our contract with ESA kicked off in May of this year, and over the next 2 years we're doing a scale up on the manufacturing for the space version of the product, and also the qualification testing, so putting it through the ringer on temperature, pressure, stress, strain, you name it, it's going to get tested over the next couple of years. So we're very excited to continue our work with the European Space Agency and really the benefits that brings for our whole customer base in terms of knowing how the material is performing in extreme environments.
Brilliant. Well, thank you very much. So that's a good introduction to the technology and the material itself. And now how about the brand and the company and the people in terms of actually delivering that to the market? So tell us a little bit more about the organisation itself.
Yeah, absolutely. So Lios is based in Dublin in Ireland. We now have 17 people on the team, myself and my co-founder Rohan, who's our CEO, I'm CTO. We both have a background in physics, and that's kind of how we started getting interested in materials, acoustics, noise, and how really to address the problem of noise, which is such a pressing issue in society, noise pollution. And myself and Rohan have been working together for over a decade. There's more than a decade of acoustic R&D gone into this product as well. And now we've been scaling up our team in the last year to bring in more commercial expertise, more manufacturing expertise as we ramp both the commercial and the pilot production into the market. So we're very fortunate that we have a really, really excellent team. It's made up of experts in kind of material science, in physics, in engineering, in production, manufacturing, in commercialization as well. We have quite a diverse team, and we have a really good, I think, environment and collaborative spirit in the team that's really driven to bring this to the market and to our customers in the next 12 to 18 months.
Yeah. Well, I think that's an excellent introduction to that technology. We'd obviously like to keep a good eye on this as it moves into the marketplace, and when those applications come through, then please do keep us informed. So thank you very much for your time.
Thanks so much.
Right, okay, here we are on the Morris commercial stand, and I'm with Dan, and Dan is going to answer some tricky questions I've got, because as we walk past this stand, we noticed some of the signs discussing reclaimed carbon fibre for the construction of vehicle panels, in particular for this vehicle here, which we're going to be talking about in a bit more detail later. when I talk to people about carbon fibre and reclamation and reuse, there's often a lot of questions around it because it's normally a woven fabric, long fibre, thermoset material, making it theoretically difficult to reuse, but here it is in reuse.
Yep.
So I'm going to ask Dan to talk us through the process of how that works, the technical challenges, and how you're solving this. So Dan, talk me through how all this happens.
So obviously this is the bonnet for the Morris JE, which is 100% reclaimed carbon fibre bodied. And so from let's say a used aircraft seat back or an old composite mould, what happens, we purchase the material from a number of companies that have chopped up that old mould or that part into different size pieces and then pyrolysed it to extract the fibres.
Okay.
Burn off the resin, pull the fibres out. And what you end up with, they put it back into a mat that is unorientated. So unlike a normal virgin carbon fibre where you have long strands and gives you strength in different directions, this is quite random, but it comes out as quite a lofted material that is then re-impregnated with a resin, and we go again. We process it again in much the same ways. But as you can see on the bonnet here, one of the challenges with the material is it's quite lofted and it doesn't like to sit into radii. So we've used some virgin material in here to consolidate better into the corners. But as we go forwards and look towards mass production in the next couple of years, we're solving some of those issues by looking at now press moulding at scale for a hot press, and we've got some trials going on right now to make some of the bigger parts of the RAM in a hot press just purely using reclaimed carbon fibre.
Okay. When you use the term lofted,
Yep.
what does that mean? Our readers might not be familiar with that.
So if you imagine a normal pre-break of carbon is probably, let's say, 0.1, 0.2 of a millimetre, this actually springs back.
Wow.
So whereas that normal pre-break, normal virgin carbon stays quite thin,
Yeah.
this, when you laminate with it, when you turn your back on it, it will spring away. So some of the surface would be still there, but some of it just lifts itself off.
Right.
And obviously, we're using 300 gram material here, so it's quite heavy. There's quite a lot of material in amongst it, but it springs back and takes the corners. You end up with a resin in the corners rather than material.
So it's almost a composite. You've got two different materials.
Yeah, the hand-laid parts we've
Hand-laid.
Yeah. So
Okay.
these are all hand-laid down.
Right.
But in the future, we move away from that.
Yeah, so you go to a different process
Yep.
where that lofted material can cope with the radiuses.
That's it. You've got two surfaces coming together much tightly controlled, whereas this is a single one with a bag.
Yeah, okay.
In a traditional laminating.
Yeah, fascinating. So, in theory, carbon fibre can now be part of a circular economy.
Certainly can.
Yeah. When this comes to end of life, could it go through that process again?
Yep. You can recycle it again up to 7 times.
Oh, wow.
I'm led to believe.
Okay. Right, so 7 times. So if that had in theory, a product life of maybe 20 years in use, 7 times 20, that's reasonable.
And obviously every time you do that, you lose a little bit of the strength out of it because you're shortening the fibres. And so that's taken into consideration. And I was talking to the Carbon Council this morning, and they're on about now trying to certify these reclaimed fibres, reclaimed materials, and give them gradings based on the fibre length.
Right.
Quite an interesting conversation.
So as a design engineer, I could be looking at a sort of standard-based process with certification.
Yeah. So you know exactly the strength of the material that you're using, rather than it being quite random, which is what we're dealing with now.
What have we got here?
This is a flax mic frame, and obviously hemp, flax, whatever you want to call it, natural material. Use the stems, woven and then impregnated again. It's very difficult to impregnate. The material quality is variable, let's say. They struggle to get consistency, but that's a natural product and that's all you do. But this proves that you can do it. Made in Italy, but there are a number of UK companies as well, SHT and that, make really good free flax materials. And it looks, certainly for us, the dashboard in the van is made of the same stuff because it goes with the whole ethos of renewable, recyclable.
Yeah.
And it looks pretty cool.
So yeah, circular, bio-based, recyclable, reusable. Yeah,
And it looks a
fascinating.
bit
I don't know.
Old English tweedy, doesn't it?
Yeah, it looks lovely. Yeah, it's got an aesthetic to it. It's lovely.
Yeah.
Brilliant.
And certainly for bike frames, I was talking to a bike manufacturer this morning, this actually gives a little bit of flexibility in the frame, whereas carbon doesn't. So you get a bit of rider comfort and that kind of thing.
Yeah, so vibration control, all that sort of thing. Yeah. Okay. Well, this has been a fascinating conversation.
Thank you.
So thank you very much, Dan, for that.
Thanks, mate.
And all the best at the show.
Cheers.
And we'll keep in touch and see how things unfold.
Thank you very much.
Thank you. Right, here we are on the Morris commercial stand, and I'm with Julian. And to be brutally honest, you can't walk past this stand without stopping to take a look at this, because you have to ask yourself the question, what is it, and why is it here, and who's going to buy it, and what's it going to do? So, Julian, talk me through it, because this isn't your average van.
John, you're absolutely right. We're glad you love it. So, this is carbon fibre bodied on an aluminium chassis, and this is all about making a van, a commercial vehicle, lightweight. As we know, weight is the enemy of range and everything electric. So not only do we get a good range, we also get a good payload. Sat here, this is 1.5 tons. We can offer a 1 ton payload, and with an 83 kilowatt hour battery, you get a range of up to 300 miles. As to your question, who's going to buy it?
Yeah.
We've had a lot of interest from retail, independent retailers, whether it's your florists, your artisan bakers, a lot of interest from tradespeople, plumbers, electricians who want their vehicle recognised and remembered when they're outside a customer's house. A lot of interest from food sellers, a lot of interest from sports and leisure industry, all because they want an extension of their brand identity, something that's going to be remembered and stand out.
Yeah, fascinating. Yes, you're not going to get this confused with any other type of van, really, are you?
No.
It's got a unique identity.
It has a character and a beauty of its own. It stands out from, dare I say it, the average grey or white box van, and should get people seen, remembered, and get people talking. Put a smile on people's faces.
So the drivability of electric,
Yes.
decent range and decent capacity due to the carbon construction, and it presenting itself as much as a marketing platform as a van.
Yes. So we're looking at customers who want something more than just a conventional van, something that is that marketing platform. It's either a mobile billboard, maybe a mobile showroom. It's going to be remembered, it's going to be talked about, and probably photographed.
Yeah.
And it'll tell its own story. So, here it is. We're glad you love it.
Can we walk round the back?
Please,
Just have a
let's
look
do.
at the payload.
Let's do it.
Right.
What I will do is just point out a design feature that we're quite pleased about. So rather than your conventional hinges on the rear doors, this is a combination of hinge and slider, which means the door closes, but you only need a foot of space behind the rear bumper, and you can open the doors fully.
Nice.
So they won't get taken away in the wind.
Yes.
They won't hit a cyclist in the face,
Yeah.
and you can get your stuff in and out of your van when someone parks you in.
No, knowing my vans as I do roughly, it also looks like a reasonably low floor height.
Yes. So we have low entry floor height. We've got space for 2 Euro pallets in the rear. There's just over 8 foot of space, so you get your standard 8x4 sheets in there for your carpenters and your tradespeople. And there's about 6 cubic meters of space in there to fill with whatever it is you're delivering.
And sliding door.
Sliding door on the side.
Yep.
And there'll need to be, for some applications, a bulkhead.
Okay.
That'll be put in, no problem.
Yep.
At the moment, we're focusing on the UK industry, so it's all right-hand drive. We've had a lot of interest from Europe, from Scandinavia, and much further afield. So once we're out there in the UK, then we'll develop the left-hand drive model for other markets.
Excellent. Well, having been an owner of a very old VW bus once upon a time, then yes, you do have to have either left or right sliding door, or potentially both.
That's right. Yep. Some like the two doors, don't they? So you can access it from both sides. And I've not seen that, but it's potentially an option.
Yeah.
It works on one side. There's no reason why it shouldn't work on the other side. So yeah, retro-styled van that's going to stand out, get people talking, get you remembered as a business or as an individual. But we're combining lots of new tech, the carbon fibre, the screens. There's a reversing camera in the door. Instead of wing mirrors, we've got cameras. So yeah, lots of modern features, but in a retro-styled van.
Fascinating. And final question, when will it be available to buy?
So we're shooting for a pre-production build starting hopefully about this time next year. That'll be out of our composites facility in Milton Keynes. Fast forward another 12 months and then we'll be into a larger volume production at a new facility.
Right. Well, brilliant. Well, wish you well.
Thank you.
And we'll keep an eye on your progress. And I'm sure we will speak again.
Excellent.
So thank you very much, Julian.
John, thank you for your time.
Here we are at Advanced Materials 2026. And, do you know, one of the things that makes shows so valuable is just getting to talk to people face to face. And would you believe it, someone I've been chatting with from time to time on Zoom calls, but never had the chance to meet, we've just bumped into in one of the aisles. And it's Rohan from Reactive Components with his colleague Joe. And so we thought we'd jump into the networking lounge, sit down and have a chat, because I wanted to find out much more about what Rohan's organisation does. And so we're going to have a little chat for a couple of minutes. First time face to face, which is great. So Rohan, very quick question, very straightforward question to ask. What would an engineering company or an OEM or a manufacturer, what problem would they try to be solving when they pick up the phone to you, hoping that you guys are the answer?
So we're specialists in advanced materials. I think that would be the best way to put it. So if a company is coming with an issue which is unique in a industry, marine, F1, automotive, something where the specifications are quite demanding, there's a lot of off-the-shelf products which they work well. They're produced en masse. The price is quite cheap on them, so they're easy to get them in. But there's some innovative products, R&D projects, which it doesn't quite fit the bill. So being experts in advanced materials, they come to us with a set of requirements which they want to meet, and the current products aren't quite meeting.
So problem solvers, basically.
Yes.
Yeah. Okay. So they're bringing. So yeah, as you say, there'll be an array of standard products in terms of material technology you can buy into. Mm-hmm. They've got an application that doesn't quite match the specifications of those, and so they're coming to you as a problem-solving organisation to deal with that.
Exactly.
Yeah. Okay. And Joe, I'm going to bring you in at this point, because when I looked at your badge, I saw product development. I like the idea of that. I used to work in product development, so just give people a clue as to sort of a day in the life of Joe. What sort of stuff do you do?
So, as Rohan said, we are a product development consultancy. So, my day-to-day would include potentially running lab tests in our on-site lab, report writing, so analysing what outcomes we found, and then potentially jumping on a meeting with customers and explaining what we found and how we've suited their challenge. And coming to places like this, we're quite fortunate to be able to do that. So really, because we're a fairly small team, we get to do everything that's involved in a business, which I really quite enjoy. Mm-hmm. So we get to find new customers, we get to speak to new customers, we're speaking to existing customers, and yeah.
Brilliant. Yeah. Excellent. Thank you very much, Joe. To give people sort of confidence in your technological capabilities, can you give me an indication of some of the problems you solved? So without giving too many secrets away, what sort of industries and what sort of challenges have you solved?
So we don't tend to work in adhesives, but there was one which was an adhesive. Mm-hmm. And because we tend to work with materials, the fact that it was using materials that we're familiar with, we were able to kind of move the team team around enough so that we're experts on the project and bring it forward. And the main issue they were having was the mixing of the materials. So it was a automotive adhesive, and there were 3 constituents, none of which are really friends with each other, it's fair to say.
Right.
So we had to bring one of them into a mix with another one, and the reason they weren't already mixed together is because it was using those materials impossible to do so.
Right.
So we had to formulate the 2 components into the same one so that they were able to be mixed together.
Right.
So you could, obviously it's not an impossible problem, but for other people it was impossible.
Yeah, so like a difficult alloying process. Almost. Yeah, okay. Absolutely fascinating. And in terms of sort of trusting the brand and the people, just give me an indication of the organisation itself. How long's it been around? What different industry sectors do you guys get involved in? Just give us a sort of an indication of the skill set.
So we've been around officially since 2018. Our MD has been in the industry for 25 years, and we have 4 engineers on the team who are quite adept and have been there for the shortest someone's been there is a year. So most of our team are quite acclimatized in the industry. In terms of our, I guess you say, track record, we've worked in basically all high performance, so marine, automotive, F1, aerospace, and I think space is the only one that's missing, but we would like to do that. And the projects, like I said, they do tend to be varied, but it's more, it's problems which can't be solved. So it makes the job fun, but harding new customers quite hard.
Yes, brilliant. Well, I think that's given us a perfect insight into Rohan and Joe's roles and the role of the organisation. So I'd like to say thank you to both of you for stopping down and sitting down and having a chat with us.
Pleasure.
And have a good show. Hopefully you can find some suppliers and some customers. And we'll stay in touch.
Yes.
And see you guys again soon, hopefully. Thank you.